Hi there, I'm Ryan KOBRICK with Paragon Space Development Corporation. And if you're watching this video, it means that I'm somewhere in Florida helping support and watch my good friend Cyan Proctor launch to space with Inspiration 4. It's a pleasure to be part of this summit, and I hope to be there next year. And please feel free to send me questions as they come up on social media or through email. I've provided all that at the end of the short kind of presentation introduction that I've got for you today. I've always been fascinated by spacesuits. I love them. I think they're the coolest thing on and off the planet. Everything you need to survive in space is right there. This is the world's teeniest spaceship. You've got life support, you've got equipment to communicate, everything you need to survive, at least for a certain duration. So I've always been fascinated with how we're able to create this cool thing and how we're going to make many more in the future. The Spacesuit 101, just in case, we've got a very diverse audience, and I want to make sure that everyone has a basic understanding of what a spacesuit does and its functions. Essentially, there are 3 tiers for life support systems. Number 1, you absolutely have to keep the people alive. So worst case scenario, you could throw them in a bubble with some oxygen and some CO2 scrubbing, and you'd be able to get them down safely. The second is to actually be able to do their job and function. So the second tier basically meaning that, when we think about zero-G EVAs and spacesuits, you actually have to have hands and ability to see and visual aid and communications so that you can complete your job. And then number 3 is comfort. We want to prevent injuries. We want to make exploration as easy as, it feels like you're not even wearing a suit. That's a huge stretch goal in design, but for the most part, that's where we're trying to go. And if we're going to be living off the planet and onto Mars, we need to be able to comfortable in our work clothes. So the rule of threes, really people should know about this, is that without pressure, you would last 3 seconds. Without air, 3 minutes, meaning a lack of oxygen. Without shelter in an extreme environment, 3 hours. Without water, 3 days. And without food, 3 weeks. And so if we look at the human body and the inputs and outputs, these are really the consumables that we need to think about when we're designing any system. We've got oxygen, portable water, and food, our energy sources kind of coming in. And then the things that we generate as humans, waste, trace contaminants, CO2 is the big one there, are really the things that we need to consider while we're designing. And, just as we think about other consumables, we also have to think about the price tag on a lot of these things. It's more of a throughput than a consumable, but it is important in terms of spacesuit design. This is not a super simple thing to do. So there's a lot of cost of development to make these things efficient, robust, and safe. And if we look at the subsystems, this of course looks more like a habitat than a spacesuit, but it really gives you a breakdown of all the different major life support systems, everything from the atmospheric revitalization system all the way to thermal control, all areas that Paragon has specialties in. Each of these subsystems then has assemblies, and each of these assemblies are then combining different technologies. And for the most part, Paragon has experience with all of these different technologies over the last 28 years of doing life support and thermal solutions in extreme environments. So a few Paragon highlights, just to let people know a little bit about us. We were part of the Constellation Spacesuit team led by Oceaneering. We were leading the thermal modeling and analysis. We even designed and delivered thermal control and PLIS hardware. That's portable life support system. That's the backpack with all the hardware on the back of the astronaut. We had a full from design to flight program, spacesuit program. The StratX mission was the first operational spacesuit built in the US in the last 30 years at the time that it was flown. And this broke altitude records and won awards, of course, and is now, if you want to go see it, you can go see it in the Smithsonian in Dallas. The Paragon dive system, again, looking at extreme environments here, just to give an example, with this hazmat suit to deal with contaminated water. Finally, just to kind of highlight on some of our major programs. I mentioned StratX. I mean, it's an all-in-one suit, and my little camera thing's blocking the words there, but we were also part of the human landing system, working with Dynetics on doing the life support and internal thermal modeling for that program. And that all came out of our commercial crew transportation air revitalization system, the CCTARS, leading to the maturity of these next designs, and now currently on the HALO program as the provider of life support with Northrop Grumman, preparing Gateway for going around the moon. So what's going on in spacesuits with, I guess you could say USA Today, because this is a USA slide coming up specifically, is the EMU, which has been the upgrade to the current ISS design, and that's in its progress. And we'll talk a little bit about that in the coming slides. You can see SpaceX's IVA suit here. David Clark has 2 suits here for both Boeing and for the Orion program. And these are kind of the next generation get me down launch entry abort suits. So IVA, for those that don't know, is the intravehicular activity suit. So that's inside, and EVA being extravehicular, meaning outside of the spacecraft, the main spacecraft. So what is the XEVAS opportunity? That's just coming out now. The RFI indicated that there might be 22 EVA suits under this contract. That would also include services. So is that servicing the suit, the tools, the training? And so the draft was out in July. And right now there's a draft RFP out for this call with the release date coming up next week. And 30 days later, the proposals will be due. And that is for $3.1 billion being invested in spacesuits over 10 years, and multiple awards are possible. So that contract wouldn't start to March. And really, this is a huge opportunity. This is like the decadal call for spacesuit technology development, and the part of the Artemis generation suits. So just kind of finalize in summary here, like where we are is that this program that's coming up for XEVAS is really focused on ISS replacement development for low Earth orbit, looking at Artemis for the moon and our moonwalkers, and then the advanced version of the suit, which is for Mars, essentially. So it's really Mars forward thinking. As you would think through the design process, you want to be able to have a suit that's modular, robust, and able to configure to these next upgradable programs. If you've got any questions, feel free to reach out to me. I'd love to obviously be there right now with everyone and be part of the ongoing chat. Maybe I'll be there for the Q&A, I'm not sure, but feel free to reach out to me. I look forward to all of our futures in space. And this is the challenge for all of you to spacesuit up, and I'll see you out there. Thanks. Bye.